A 5-kilogram block that is initially at rest on its frictionless surface is hit by another 5-kilogram block, moving at 10 meters per second. If mechanical energy is conserved, what would the kinetic energy of the two-block system be after the collision?
Conservation of mechanical energy. The only mechanical energy in this system happens to be kinetic energy. The kinetic energy comes from the movement of the boxes. And the equation for the kinetic energy is 1/2 mv squared.
But, teacher, why does it say frictionless surface?
If the surface isn't smooth, it would slow down the system and convert the kinetic energy to heat energy produced by friction. That would mean that the mechanical energy will no longer be conserved.
Where do we find frictionless surfaces?
Where there's ice. So let's pack up our stuff and fly off to where there's ice. The two 5-kilogram blocks are on a frictionless surface.
To determine the kinetic energy of the moving block, we use K is equal to 1/2 mv squared. In order to work out the formula, we have to plug in the correct numbers. M represents mass again, and the mass is 5 kilograms. The V is for velocity, which is the same thing as speed in this case, and the speed is 10 meters per second. Don't forget to use PEMDAS, which means that you're going to work out the exponent first. So you have 10 squared, which is equal to 100, because 10 times 10 gives you 100. Once you work out the 100, then you multiply that 100 to a 5, and then you multiply it to the 1/2. Okay, so you'll end up with 250 joules for your kinetic energy. So the kinetic energy of the moving block only is 250 joules. Now let's look at the block that's at rest. When anything's at rest, the speed or the velocity is equal to 0. So we use the same formula, K is equal to 1/2 mv squared. The mass for the block at rest is also 5 kilograms. So we're going to plug in 5 into the M. But since that's at rest, the velocity will be 0. And so we're going to plug in 0 into the V for velocity. Once we plug the 0 into the V, if we square 0, we get 0. And then if we multiply that 0 to the 5, we're going to get 0. And then 0 times 1/2 will equal to 0 also. So the kinetic energy of the block that's at rest will equal to 0 joules. To find the total energy of the system before collision, we have to add the 250 joules for the 5-kilogram box that's moving, and the 0 joules for the box that's at rest. And 250 plus 0 gives you 250 joules total.